This is AQA GCSE Chemistry. It is the higher trilogy paper from 2018, and this is question 1. So I'm going to put the whole question up so you can have a go for yourself, and then we can review. So here is 1.1, 1.2, 1.3, 1.4, and finally 1.5, and it's an 8-mark question in total. So we have got here a question about electrolysis. A student investigates the mass of copper produced during the electrolysis of copper chloride solution. We have the apparatus set up. We can see we have an inert carbon electrode and we've got a copper chloride solution. Which gas is produced at the positive electrode? Now, on this, we've got to think that the positive electrode will attract negative ions. We're also thinking that this is going to be a gas. So we're looking for a gas that would form negative ions. And what we can see here is copper chloride would break down into copper and chlorine. Chlorine ions have a charge of -1, attracted to the positive electrode and become chlorine gas. Now, copper is produced at the negative electrode, but that wouldn't always be the case. It's dependent on the metal. So what does it tell you about the reactivity of copper? And what we're looking for is that copper is less reactive than hydrogen. In any aqueous electrolysis experiment that is carried out, if the metal is higher than hydrogen in the reactivity series, then you will actually make hydrogen gas at the cathode rather than the metal. And we see that with the electrolysis of brine, sodium chloride. We don't make sodium metal, we make hydrogen gas. On to 1.3. And you're being asked here to determine the mean mass of copper produced after 3 minutes. Well, if we take a look at the data, we can see after 1 minute we have 0.6, after 2 minutes we have 1.2, and after 4 minutes we have 2.4. And I've put those over on this side with a space for 3 because we can see a clear pattern going up. It's going up by 0.6 each minute. That tells us it's going to be 1.8 milligrams. Moving on to 1.4, calculate the mass X of copper produced in experiment 2 after 5 minutes. And you can use the table that we have here. Well, at 5 minutes, we have got the mean and we've got 2 of the values used to calculate that mean. So we're going to do the normal mean calculation, but the X is on the left-hand side here. I can then multiply both sides by 3. And that gives me 3.02 plus X plus 3.01 equals 9.18. And if I then subtract the 3.02 and the 3.01 from each side, that tells me the value of X is 3.15 milligrams. Moving on to 1.5, the copper chloride solution used in the investigation contained 300 grams per decimeter cubed of solid copper chloride dissolved in 1 decimeter cubed of water. But the student took a 50 centimeter cubed sample of that solution each time. So what mass of solid copper chloride was used in each experiment? Well, let's break this right down. There are 300 grams in 1 decimeter cubed. We're not using 1 decimeter cubed, we're using 50 centimeter cubed, which is 0.05 decimeter cubed. And that is significantly smaller. So we're expecting our answer to be significantly smaller as well. And the way we actually get to it is we will take our 300 that we have in 1 decimeter cubed and we multiply it by 0.05. And that takes you to 15 grams. And that takes us to the end of the question.